Well, thanks for coming to my session instead of the one next door. I appreciate that, especially at the end of the day on Friday. So web security on you. So I'll mostly be talking about how to keep cheaters at bay. So I'm Matthew Miner. This is my co-founder, Brad. We work on a product called Lumos. It's a web services company, so we do backends for games. So if you need analytics or high scores and achievements and that sort of thing, you can come to us. So we deal with security a lot on an everyday basis, so it's a topic that's near and dear to our heart. If you'd like to follow along with your laptop, your iPad, your iPhone, the slides, you can go to unite2013.lumospowered.com. Also, the slide source and the source code of the demo game that we have, it's all available at github.com/mminer/unite2013. That link will also be at the end of the slides if you see something that you think looks interesting. All right, let's move on. So typically, security can be thought of as three things. There's confidentiality, integrity, and availability. If you ever go to any security class, these are what they pound into you at the beginning, so thought I would too. All right, so we missed a slide there, boss. Let's go down one. All right, so confidentiality, basically think of that. I think everyone kind of grasps this one. You kind of want to restrict players to viewing data that, only viewing data that they're allowed to view. Fairly simple. The next one, integrity. You always want to prevent players from tampering with data before it gets sent to a server. You know, when they send data or get data back from the server, you want it to be the right data. And the final one, which is a bit less intuitive, is availability. When the player wants data or wants to play their game, they should be able to. So no other player should be able to disrupt someone else's play session. It's kind of the shtick with that. All right. So, but our focus for this talk is just going to be integrity. So we want to be able to prevent players from tampering with data. So I'm just going to give you some quick tips on how to prevent the easiest targets that they tend to hit. So really, we want to keep the game as fair as possible for all players and as fun as possible for all players. We don't want one player to go in, submit a whole bunch of high scores that they didn't actually achieve and ruin the leaderboard for everybody. So an example. So we'll give you some quick tips on how to do that. I should really emphasize that you're never going to be able to keep your game totally secure, but these are a few quick tips that can help. So more concretely, I'll be talking about just three topics. The first one is how to prevent memory hacks, so how to prevent people from downloading a program that can change variables in your game, like, say, a score or something, and then having that submit to the server. I'll be talking about how you protect your game, or how to protect the communication between a game and a web server. Say, if you have a leaderboard system somewhere, you want to be able to prevent people from tampering with the data as it goes along the wire. And also just a few ideas on how we might enforce rules in a multiplayer game when people are actually competing directly against each other. All right, so as I said, the reality of it is we're not going to be able to stop all hacks. Hacking games is really fun. It's kind of a game in itself. Sometimes it's more exciting than the game you're trying to hack. So I mean, you're up against some really bright people that really have fun hacking games, so it's impossible to stop everything. But we can try to make it more difficult. You can see this screenshot up here. It's from a website called, what's it called? It's called hackedfreegames.com. There's a million of these websites where people just share tips on how to break into games. They give you the code to hack them. So that's what you're up against, people that form entire communities around this kind of thing. So, but we want to make it more difficult for them. So security doesn't always matter for games. Sometimes it's really fun to use cheat codes and to cheat in game. I used to play Tony Hawk's Pro Skater 2. You do cool hacks like you could make the gravity all crazy. That was super fun. In Doom, the only way I was ever going to beat that game was using IDDQD and throwing on God mode. So that's not a bad thing. I mean, why not let players do that? If they enjoy it more to cheat, then let them. However, when they're interfering with other players' enjoyment, that's when it's a problem. Also, when you're losing money because of it. So those are two big scenarios where you really do want to bother with security. So something like leaderboards, if someone will ruin a leaderboard for everybody else, like you can see the screenshot here from Game Center, a bunch of different players have managed to hack the leaderboard, and they all submitted a ridiculously large score, which is the maximum for a 64-bit integer, as you can see. So I mean, that just makes the leaderboard useless, and no one else can enjoy that. Anytime you've networked multiplayer, you don't want someone with an aimbot to be able to make it not enjoyable for everybody else. And anytime there's a purchase happening, you don't want players to be able to purchase things that they would normally pay for. You don't want them to be able to hack that, so you don't want to lose money. So the first thing I want to cover is memory hacks. It's very trivial to change variables in your game. There's tools like Cheat Engine. That's for Windows. There's a couple for Mac called Bit Slicer and the Cheat. Basically, there's tools that really easily let you modify a variable in your game. So that could be scores, the player's health, how much ammo they have, basically anything. It's really easy to do. Your grandmother could do it. And it's virtually impossible for your game to detect this kind of thing. It's really hard to know, like, oh, this player is cheating. So actually, let's just we'll do a demonstration of this. So we're going to be using a program called Bit Slicer and a game that we built recently. And we'll show you how this works. So we made this amazing game. You fly around and shoot asteroids and other planes. So currently, Brad has a score of 0. He rarely goes above 0, so he really needs to cheat in this game. Yeah, so his score is 0. Let's increase that. All right, so Brad's feeling the heat. He's got a score of 300. He's going to open this handy-dandy program called Bit Slicer. It's as simple as you just search for that value, the value of your high score, which is 300. You get a whole bunch of values, but now he can narrow it down. So these are memory addresses. I don't know if you can see that, but they show the memory address and the values of them. Now we can just kind of refine his search to 400. He's got fewer values. Maybe he'll do it once more. So basically, this is a process of narrowing down the search until he finds the exact memory address that holds that value of his score. I want to turn secure mode off. Okay. So he can simply edit that variable value to something else. And it's changed. Can you? Oh, it's not. Okay. So now you can see he now has a score of over 9,000, which is a score he'd never be able to get normally. No, that's not true. He's good. So just by trivially using a program they download off the internet and just a slight bit of knowledge, he's able to change the score. And when we submit that score, it'll mess up everything. So there's a few. Whoa, big score. All right. Awesome. So there's a few ways we can prevent this, though. Oh. All right. So I guess the way we need to do this is we need to encrypt the values that we're trying to keep safe from people, make them so that they're unreadable in a memory hacking program like the Cheat. And then whenever you need to just display, you either keep a dummy variable around for just displaying, or you can just decrypt it at the time of. So this will be enough to fool the kind of the entry-level script kiddies, people that just download a program and read a quick article. So it's fairly effective at that. All right, so there's a C# class called SecureString. So when you search for like, how do I keep something safe in C#, you might stumble upon this one. It's in the system.security namespace. It's really designed to store things like passwords and credit card numbers, usually in web apps that use .NET. So it's pretty robust. Yeah, so it basically makes strings unreadable in memory. Let's see some code for that. All right, so the code, can you guys read that? It's pretty small. If you can't read it, the slides will be available later. There we go. Magic. All right, so the code's a bit gnarly. That's kind of the unfortunate part of this. Every time you get the score, you have to first convert it from this container format called SecureString. You have to convert that to a string. Then you need to release the pointer that had that there. You need to parse that string into an integer, and then you got your score. And then, make it even worse, every time you set the score, or any value really, we're just using scores as an example, you need to cast it to a string, you need to make that into a character array, you need to append each character one by one to the container because there's no good API for this. Anyway, it's an enormous pain in the ass, but it does work. So we'll just do, let's try to hack our game again using a different method. So we have our demo game again, which if you have any suggestions for what to call it, let us know. Right now it's just called High Score Demo, which is pretty great. All right, so Brad's going to get a hopefully higher score than before. He'll switch over to Bit Slicer. He's going to search for the value 300, which is his current score. All right, he found a whole bunch of values. Oh, he just died. All right, we'll try this again. Oh. Our on-GUI system is lacking. All right. I wasn't joking when I said he's not the best player. All right, so he's got a score of 200. You can search for it, try to narrow down where that is being stored. So we got a whole bunch of memory addresses there. All right, now he can just start the process of narrowing it down. All right, he's got a few. Oh, he just died again. All right. So now he can change all those values to say 300. He can change them to something else. Score far, far over 9,000. Now when he goes back to the game, it's intact. He didn't actually change the memory address that held the score 300. That was protected in secure string. It's encrypted somewhere in memory. We don't even know where. So that worked pretty well. So that's one solution you can use, which is built into C#. All right. Oh. Go down. There's a previous slide. All right. So there are some pros and cons to this. It makes memory hacking very difficult, almost impossible to do. However, the encryption operation is pretty slow. So if you put the decrypt operation in something like on GUI call, which executes like really quickly, that'd be really bad. That'd be a major performance hit for just like one variable. So you don't want to do that. You can keep a dummy variable around that you just update every time the score updates. But then you can, when you actually send the score to a server, then you can use the decrypt operation on the actual secure string. The API really sucks. And the biggest caveat is that it doesn't work on mobile or web. It only works on desktop, which is kind of a bummer. It relies on some marshalling stuff that only works in the just-in-time compilers that the desktop uses, so that's the downside. Luckily, there's another way, an easier way maybe. So we can use the XOR operation. This is a bitwise operation in C# that's pretty easy to use. So basically, the idea is you generate a random key at runtime. Every time you save the value, you can XOR it with this key. And then when you want to get it back, you can XOR it again with a key and get the original value back. And then what's actually stored in memory resembles nothing what the actual value is. So let's see some code for that. All right, so on awake, you can generate a random key. Just a number will do anywhere, any number. Then every time you get the value, you use the little hat, the caret. That's the XOR operator. You can, when you get it, that will give you the original value. And then when you set it, you just perform the XOR operation. So XOR operation both times. So say the key generated was 999. Then when you save the value, a value of 100, what's actually stored in memory is going to be 10091. Then say if you store a value of 200, the value is 10183. So you notice that it's not plus 100. It's pretty unlike the original value. So script kiddies aren't going to be able to simply search for that value and find it in memory, which is nice. So it becomes much more difficult to isolate that memory address and change what's in it. All right, I have another slightly better implementation of this. Let's go to the next slide. Oh, did we skip it? There we go. All right. Maybe even better, to fool more people, every time you save the key or save a value, you can generate a new key to XOR the value with. And then every time the val variable that we have here is saved, we don't know what it's going to be. So even if they manage to figure out the key they use to XOR the value with, they won't be able to do it the next time. So it works even better. All right. So pros and cons of this. The XOR operation is extremely fast, which is great. It's just a basic bitwise operator that's available on all platforms. It's right up there with plus and minus as far as speed goes. Hacking is difficult, but not unfeasible. It's not as difficult as hacking secure string, for example. If someone can figure out that memory location that your that your value is being stored in, they can still modify it, which we couldn't do with secure string. So I mean, if they know what's going on, and if someone's very clever and can watch what addresses are being changed and narrow it down that way, they can still do it. So a very determined player might still be able to reverse engineer what you're doing and break it that way. So there is some caveats. But otherwise, it's a pretty good system. All right, so there might be other solutions out there. On the asset store, there's a package called Secure Client. It's $35, which is pretty cheap. I didn't make it. I just think it works pretty well. So that will do everything I just explained for you. You don't have to think about it. You might find lots of tools online. There's one called GameGuard and Punkbuster and some other things that help you manage protecting your in-game variables. Most of these are pretty old. They're using some AAA titles. I don't know. They might be a good solution if you have a lot of money in your Blizzard. If you're not, though, Secure Client's $35, which is great. OK, so let's move on to topic number 2, which is, so it's great. You've protected your game from people being able to modify those values and like submit bad high scores or earn achievements that they don't actually have. It's still pretty trivial, though, once you actually send a value to a server to modify that value in transit. So we'll demonstrate this using a program called Wireshark. It's free and open source, and it makes it pretty trivial to see exactly what gets sent from your game to your server. So once you know what a request to a web server looks like, it's pretty easy to mimic that, change it, and then reap the rewards. Luckily, solid solution exists, but let's first, we'll first show you what we mean by intercepting a request. So we're going to open a program called Wireshark. So this is Wireshark, very pretty. We have a game. We'll submit. We made a little server on our computer. I'm going to open that up too. OK, so there's 3 pieces to this. We have our game. We have our, this isn't a web browser. This is our leaderboard system that we built that's pretty insecure. And we have Wireshark waiting in the middle to see what gets transmitted from the game to that server. So Brad's just going to get a score of something or other. He's going to start recording everything that passes from his game to the server. We have to keep switching windows because for some reason OnGUI is going wonky. So now it's a simple matter of finding, these are all the requests that went from his game to the server. I can see one there. There's a post request at the very top to the server. You can see what URL it hit. So he's going to copy that. He's going to go into his terminal. He's going to use a program called curl, which just can make web requests for you. He's going to make a request to that URL. Now he just needs to know what data was sent and what that data looks like, what the server is expecting. So he can simply you can copy it here. Beautiful. So as you can see, I don't know if you can see that. Do you want to make it larger? Bear with the copy and pasting here. All right. So he's about to make a curl request. Curl is available on all platforms if you're not familiar with it. So if you can see what he's sending there, it's a little bit small, but basically it's just a JSON object. So he's sending a score and his name. So all he needs to do now to send a different score, he just can modify that score value. He can change it to whatever score he wants. And the server won't know any difference. He won't know that he didn't send that from the game. So flip back to the server now and refresh. And there's his score. He's a jerk. He just submitted a score that's way above everybody else's, and he didn't actually earn it, which is a bummer. Nobody likes this guy. I like this guy. He's a great guy. So luckily, there's really great solutions for preventing this from happening. So like I said, it's easy to mimic a request, but it's even easier to protect it from happening. So you might have heard of a technology called SSL, also called TLS. It's kind of the S in HTTPS when you go to your bank website, or most websites these days. It's great. It encrypts everything that gets sent from a client to a server. So this, and it also includes checksums. So not only can you not eavesdrop on what's being sent, you can watch what gets sent, but it's all encrypted. There's also checksums to prevent you from tampering with the data. So we'll just show a quick request to Google. We'll use Google as our demo here. So if we make a request to just regular plain Jane Google at http://google.com, we'll send it some bogus data. So we'll just send it something. Google will accept it. It's cool with us. The old hello world is a classic. All right, so did you open up Wireshark there? So he's going to start a new Wireshark session so we can watch what gets sent from his terminal to Google. All right, whole bunch of stuff. All right. Now if you hit stop, you'll find the HTTP request. There it is. If he looks at the data being sent, you can see right at the bottom there it says hello world. You can see exactly what is being sent. But now we can use the secure version of Google, which is the SSL protected version. Simple change. Basically the exact same request, but this time, everything he sends will be encrypted and protected by SSL, so he won't be able to actually see or change what's happening in Wireshark. So we'll just demonstrate that shortly. All right, he made the request. This data got sent to Google. Google could have read it in if they wanted to. They're just ignoring us right now, though. So now there's no HTTP requests anymore. It's just all these TLS requests you can see there. Now if we go to see what actually got sent to Google, it's just this encrypted gobbledygook there. So a bunch of random numbers and stuff, so we can't actually see what got sent, which is great. So anyone that's watching the request being sent can't simply copy that and mimic it, which is exactly what we want. All right, moving on. So there's some pros and cons to SSL. Very few cons, actually, which is the best part about it. For one thing, it's cheap to implement SSL. It's like $10 a year for a certificate at, say, a company like Namecheap. It's a really trusted, tested technology. So I guess there really are no cons to this. It's kind of, if you run your own server, it can be a pain in the ass to set up SSL. But that's kind of the only con. So if you put the effort in, you'll get rock solid security from your game to your server. So I highly recommend it. But there is another way. Maybe you have a web server that maybe you just don't want to put the effort in. I don't know. There's other ways to do this to protect the integrity of your data. So one technique is hashing up the things you're sending to the server from your game into kind of a checksum. So the way you do this, you take your data that you want to send, say it's a score again, you add it to a secret key, so some key that both your game and your server knows. You combine them, you calculate a SHA-1 or an MD5 hash. Then on the server side, once the server receives that score, they can recalculate that hash and then compare them. So this prevents tampering with the data. I'll show you some code in a second if you're totally lost. So this prevents tampering with your data, but not eavesdropping. So if confidentiality is really important, which is something that SSL covers, this technique won't. So let's see some code. Okay, scroll over there. Okay, so First, you just import a couple things that are available in Unity. You have a secret key. Ours is Unite 2013, ideally a key that isn't easily guessable. Then when you want to calculate a hash, you simply add your score to your secret key on that line there where it says get bytes. It's a few complicated steps, and then out of this function here, you get a hash, which you can include in your request. And then on the server side of things, let's go there. All right, on the server side, this is pretend your server's in Python here. When you handle a request, you simply recalculate the hash with the secret key that you know as well. You add it to the score that they sent, and if they're the same, then you know that the data hasn't been tampered with, and you can save the score. If it's different, you can just reject that and call them out on it. All right, so we'll just do a demonstration here of doing that. So in our game, which is going a bit crazy there, all right, so Brad's going to submit a score here. And before he does, he's going to open up Wireshark so he makes sure he can see what the request is. So we'll create another Wireshark session. All right, so Wireshark's recording everything that goes from the game to the server. All right, and now he just submitted his score. It went to, you can see what URL it went to. And you can also see the JavaScript or the JSON object that he sent. So he's going to try to replicate this and change the score of it. So once again, he's going to use his handy dandy old friend curl, old man curl as I like to call him. All right, now he's going to find out the data that the server's expecting. All right, so this time, it's exactly like before when we submitted a bogus score, but I don't even see it. We'll zoom in for you. All right, this time, he's sending the score, his name, but this time it has a hash included. So this is a hash that we calculated at when you sent the score. So now, if he tries to actually modify his score, he'll change it from 200 to, I don't know, whatever you'd like to have. Before, when you changed the score, the server just happily accepted it, said, great, you got a score of 9999, awesome. This time he'll modify it. A big one, impressive. But this time, the hashes didn't match all of a sudden. They would have before if he didn't modify the score, but now that he modified the score, the hash that he sent doesn't match, and it didn't work. So it's a win. No cheating today, Brad. All right, so pros and cons time. Oh, and those are some tips first. So this relies on keeping a secret key that both you, the server, and the game know safe. And that's can be incredibly difficult. Anyone that's done security will recognize that embedding a secure, something that's supposed to be secret inside a client can be kind of foolhardy. So a pro tip, don't hard code that value. If someone has a reflection tool, they can sometimes extract that key. What we found, though, is that if you assign a key in the inspector, like you have in a public inspector variable, and you assign it there, it's very difficult to extract. I haven't been able to do it myself. I tried very hard. So that's something, if you're trying to keep your secret key safe, try assign it in the inspector instead of hard coding it into your game. Another tip, sometimes you might have a request to a server, that if it was executed multiple times, it would be a bad thing. Like say you have a call where someone purchases, I don't know, something. If they purchase something and they call it multiple times, maybe they get to purchase multiple things. Here you can employ a token, so the server can send a one-time use token. They say, attach this token to your request, and once it's sent to the server, it'll say, okay, we use that token, we can never use it again. I won't go too deep into one-time use tokens to prevent replay attacks, but if that's a concern for what you're doing, then you look into it. For the example we just did where we submit a score to a leaderboard, it doesn't really matter if someone sends the same score multiple times, because that's the score they earned anyway. But for other things, it could be a concern. All right. So some pros and cons for the technique we just demonstrated, the hashing up the parameters. It assumes that confidentiality is unimportant, as I mentioned. So if it's important that the user can't actually see what's being sent along the wire, like say it's a password or something like that, or if it's important that another person, a third party, can't see it, then this doesn't really work. And also, like I mentioned, it relies on the impossible task of trying to keep a secret key safe. I think we might be able to do pretty good, but I don't know. It's an assumption that might not always work out. Okay, so our third topic. When people are actually playing together, like a first-person shooter or something to that effect. So Unity's peer-to-peer networking library includes a handy call. It's one-liner, network.initialize security. It does a whole bunch of good stuff for you to prevent certain types of attacks. It's a freebie. If you're using Unity's peer-to-peer networking, there's no reason not to use it. So check that out. If you're using a third-party library like Photon to do networking, they include a lot of encryption routines, and they have something called secure WebSockets that encrypts all your communication to other players using SSL, which is really great. So almost any web service or networking library they use has ran into this problem and usually either implemented SSL or found other solutions. So definitely, you're probably in good hands. You're definitely in good hands with something like Photon. So most web services you use will have thought of these problems. So you're pretty good to go. So the key thing is here, never trust the client, never trust the game. By default, you just have to assume that your player is being sneaky. So every time they request to do something, every time they request to buy an item, you have to check if they have enough money to buy that item. You just have to assume that they're doing something wrong, and so you gotta check it at every step. Also, people are gonna thwart your systems. Absolutely, it's gonna happen. So your job is just, you have to be vigilant about removing hacked high scores. If you have a high scoreboard and someone manages to get through all your security, just remove those items. Also, if you're doing something like a multiplayer game, like Counter-Strike or something, just implement a reporting system so that people can say, hey, this other player is obviously a cheater. So then if they get enough of those, then you can maybe ban the user. But just be cautious about this, though. You don't want to be too aggressive about banning people. We had a friend who was very good at Counter-Strike. So anytime he played on someone else's server, he'd always be accused of using aimbots when he was just actually a good player. So it'd be really detrimental for him to be banned. And he did get banned a lot, which is pretty disappointing for a legitimately good player. So I mean, there can be a lot of false positives when you're trying to find players to ban, so just be careful that you don't go overboard there. So just some things, when you own the server and you can actually check this kind of stuff, some things to watch for. In a first-person shooter, if the player is moving inhumanly fast, just darting around the map way quicker than it's actually possible to do, they might be cheating. If they have more ammo than the level actually provides, if they hack the game, like do a memory hack and get 1 million ammo of a gun when there's not actually nearly that much in the level, then you know they're cheating there. So you can do checks like that on your server. Or if their score is impossibly high, like if people are getting the maximum amount that an integer holds, that's probably a good indication that they're cheating. It'll kind of depend on your server software what sort of checks, like how to do these checks, so I don't have any code samples for you, but some things just to consider. All right, so there's always going to be a weak spot in your system. We've covered, memory hacking, which is always an easy weak spot to target, and the communication between client and a server. So there's always a weak spot. Moving on. So one of them is certainly player prefs. So if you use player prefs, it's just an XML file. I don't know if you've looked at it, but it's just an easily modifiable plain text file. So if you want to store something like a score in that, you're going to have to use encryption. You're going to have to encrypt the score so that people can't go in and modify it and whatnot. So there are some really great like security functions in Unity for doing this kind of stuff in this system.security namespace. Definitely check them out. You could do something like an XOR, again, against a sufficient long string. Again, it relies on you being able to keep that string, that secret key secure, which is tricky. Yeah, so just avoid storing really sensitive stuff in player prefs that people can modify. All right, so the question always comes up, should I obfuscate my code? Like, should I use a program to change all the variable names and the function names to make it harder for people to find out what I'm doing? In general, if your security relies on secret algorithms, it's probably a bad sign. Your security should be such that you can tell people how you're doing it, and it's just very difficult to break that. Also, obfuscation can cause all sorts of problems, especially when you're trying to push it to mobile. Some obfuscators can be too aggressive sometimes and break things. Just show of hands, has anyone tried obfuscation for their games, or does anyone use it actively? One guy? Yeah. Oh, it's an ActionScript? Yeah, there's a lot of great ActionScript ones. Oh, it's a nightmare. All right. Yeah, I'd love to know if you guys use it. So it's a topic I'm very curious about, actually. It's certainly not a silver bullet. It is definitely easier to protect what you're doing if people can't read it. So we'll just show a demo now of like how people can read your code very trivially. So we have a program here called .NET Reflector. There's also ones for Flash games and such. Basically, when you export a game, your code is stored in these DLLs files. So you can simply find those. You can open them up. We can see all the classes that you made. You can see there's one called Leaderboard API. It shows all the function calls that we built, all the constructors. You can actually see what the record score function looks like. You can see how that works. So you just kind of have to assume that everyone playing your game can actually read the entire code base, because a lot of games they can. So obfuscators might be a good idea. They might not be. Your mileage may vary. But I'd love to hear any stories about that. All right. So if you want to find out more, I just covered a few basic techniques to kind of remedy the biggest weak spots when it comes to a game and when you're just talking to a web server. Coursera, it's an online learning system that's free. They offer a really great course that Stanford offers called Computer Security. It's a good primer on all sorts of security that includes protecting memory and includes things like SSL. There's another very good book called The Web Applications Hacker's Handbook. If you're setting up a backend server of your own and you're not using something like Photon or Lumos, then it's very relevant for all sorts of security techniques. Protecting your server alone is its own topic and very difficult to do. Also, check out the websites and forums where people hack games and do it for fun, because then you can find out what techniques they're using. Look at games that have been hacked and like read about how it was done. Usually you'll see like, oh, my game does the exact same thing. It can be hacked in the exact same manner, but then you can get ideas of how to remedy that. All right. So that's my talk. You can visit us online. We're at lumospowered.com. You can tweet at us if you're cool and hipstery. It's at lumospowered. And also, like I said, the content of the slides and our code samples are at unite2013.lumospowered.com. I think we have quite a bit of time for questions. So if you guys do have any questions about any of the content or anything of the sort, if you have any great jokes, there's microphones on the side there. Just let me know. Any questions? Going once. All right, we got one. Excellent. Got two.
Are you aware of any application hacking tools on iOS or Android? Like not web side, but client side?
Right. I mean, you can always jailbreak your phone and then grab all that data and just kind of run it normally. So I mean, on its own, it's hard to kind of hack iOS games unless you jailbreak your phone, and then it's like all bets are off. So I don't know of any like specific tools like BitSlicer that people are using, but certainly don't assume that just because it's on a platform like iOS that makes running external tools difficult that it's impossible. So yeah, I mean, that's how most games are hacked. People jailbreak their phone first, download your code, check it out, try to run it locally, that sort of thing.
Hi, do you know of any techniques or tricks to hide or make it harder to find a secret key inside a client code? I've talked with people who say, like, break it up into multiple strings and spread it around the code base and stuff like that. It seems like a pain. I'm just wondering if you've ever tried to hide it inside client code before.
Yeah, like I mentioned the inspector trick, like make a public inspector variable and then assign it in there.
Right.
So inside a mono behavior. That seems to work pretty well. Another thing I've done before is like created a character array kind of thing, and like instead of just a string block, a character array where you can put different chunks of it in. Yeah, so there's ways you can like break up a secret key and then recombine them when you need it. They're all kind of hacky and not foolproof for sure.
Right. Do you find they're effective at all, or?
Yeah, like I found storing a secret key in the inspector works pretty well. I don't exactly know how Unity stores that stuff.
Right, so that's a Unity-specific kind of thing.
It's a Unity-specific thing, yeah, absolutely.
Cool.
Or you could store it in something like secure string if you're doing a desktop game, and that'll make it difficult to find. But yeah, there's no real foolproof techniques, unfortunately. Basically, you have to assume that your code is readable by everybody, including any hard-coded secret keys. So it is difficult.
Yeah.
I'd recommend the inspector route, but I'd love to know if someone can actually extract something from the inspector variable, because then my advice would be totally moot.
Okay, thanks.
Yeah, no worries. Any other questions? Yeah.
Are there any specific considerations for web player?
Sorry, for what?
For web player?
Web player. So luckily, web players are a lot more difficult to use reflection on, which is nice. So you don't really need an obfuscator in that case, because Unity kind of does that on its own. But no, there's no real additional considerations for a web player. It's about as secure as any other deployment target, with a few added benefits. Unfortunately, like I mentioned, you can't use certain security and cryptography stuff in the web player because it doesn't include those DLLs or those namespaces. But yeah, it's pretty consistent across most platforms as far as that goes. You, sir.
Hi. Did you know that the www component doesn't actually properly implement the HTTPS security checks in Unity?
Is that right? Oh, okay, because when I tested
it, if the certificates don't match, it just ignores it.
Oh, is that right? Okay, I'll have to check that out.
And if you would know any kind of a solution that would actually, properly implement that, I would, be
Right.
glad to hear about that.
Yeah, I'll have to check that out. That's a good tip. Yeah, I know. Yeah. There is another alternative to the www class that I found called, I think, Unity Web or something, which may or may not support SSL. So that might be a worthwhile package to look into, just simply not use Unity's built-in www class. But that's a good tip. I'll check that out.
Yeah, thanks. It has crossed my mind to,
Yeah.
try something else.
Yeah. Unity's networking, or www class is a bit unfortunate. Any other questions? All right, thanks everyone.